Now, as you can imagine, finding the inverse tangent is a little more tricky than finding the inverse sine or cosine. So if we have our inverse tangent, recall that tangent of an angle is sine of that angle over cosine of that angle. So it should follow that the inverse tangent would be the inverse sine over the inverse cosine. So because we're limited here, we know that inverse sine has to be to the left of the y-axis, and inverse cosine must be above the x-axis. So we're kind of limited to this first quadrant right here. Now, we're going to want something in the y-coordinate divided by something in the x-coordinate that's going to give us root 3 over 3. If I look at my values here on the unit circle, clearly 0 over 1 and 1 over 0 are out. Neither of those are going to give me root 3 over 3. So it comes down to one of these ones. Root 2 over 2 and root 2 over 2 are the same. So that if I divide those two, it's going to give me 1. So it's either between pi over 3 and pi over 6. So if I divide square root of 3 over 2 divided by 1/2, as in pi over 3, notice the 2 in the denominator crosses out, and I get root 3 over 1, which is just root 3. So it's not pi over 3. That leaves us with only one option, pi over 6. So let's put sine over cosine. We get 1/2 over root 3 over 2. 2's cross out, I get 1 over root 3. And if I rationalize this, notice now I have root 3 over 3, which is my answer. Therefore, the inverse tangent of root 3 over 3 is pi over 6. Now, for the arctangent of 1, I kind of gave you a little hint for this earlier, but we're going to need a sine and a cosine that have the same value. And that's going to occur right here at pi over 4. We've got root 2 over 2 over root 2 over 2, and that's going to give me 1. So my answer for arctangent of 1 is going to be pi over 4. So go ahead and try this question on your own. Notice in this one you have a negative radical 3, so you'll have to go outside of the first quadrant.